Yeah, they're not very good. Yeah, 3% hydrogen peroxide is kind of weak. Oh well. So the bubbles are coming from the oxygen, and it is trying to. You know what? Let's see what happens if we just add solid potassium iodide to it.
Okay, so
Yeah, that's better, huh?
oh, is this something you? Oh.
Yeah, this is the thing I've been working on for the last couple weeks. Like, can I make it so it actually goes a lot faster and purify the hydrogen peroxide? There's lots of techniques online, but none of them have really worked.
Deja vu.
Yeah, deja vu, exactly. So anyway, so there's that. That's a decomposition. Now I did this reaction for you guys a couple weeks ago. So this is the nitrogen triiodide.
In this experiment, we are looking at the explosive decomposition of a compound of nitrogen triiodide. This brown compound is so sensitive when dry that just touching it with a feather causes an explosive decomposition. Nitrogen and iodine. Like this mousetrap, which releases potential energy from the spring, the nitrogen triiodide releases chemical energy. When it decomposes into its elements, nitrogen and iodine. In this experiment, we are looking at the explosive decomposition of a compound of nitrogen triiodide.
So that is what we had in the Fuel a couple weeks ago. So can you balance nitrogen triiodide? Okay, put your phones away. Don't use your phones as a tool. We don't use your phones as a toy. Only as a tool. Still going. So can you balance this? Please balance this. Okay, lowest common multiple of 2 and 3 is 6. Something to think about. 2 and 3. Once you got this balance, give me a thumbs up. About 2/3 of you? Good enough. Okay, so Devin, how did you balance this? How did you balance it? Hey guys, I want to hear Devin's response, but I can't hear you if you're talking. Continue.
2 and I 3 and then
3 in front of 2 iodines?
Yeah.
So let's check. 2 nitrogens, 6 iodines, 6 iodines. Sounds pretty good. Okay, so synthesis, 2 things together become 1 thing. Decomposition, 1 thing becomes 2 things or breaks down into its elements. Probably your favorite is decomposition, or sorry, hydrogen carbon combustion. In a hydrocarbon combustion, some kind of fuel reacts with oxygen to produce carbon dioxide and water.
Human combustion?
Maybe. But generally, in this class, it's going to be some kind of hydrocarbon, something with hydrogen and carbon, reacts with oxygen to produce carbon dioxide and water. So, I want to show you one. It's actually kind of interesting. And it's super easy because it's just CH2O. This is acetone. No, it's formaldehyde. There's one thing that I want to do. I want to do methane bubbles with you.
Oh yeah, pure frost.
But makes me a little goofy. So acetone is kind of an interesting chemical. It's COCH3CH3. But first we're going to do methanol. Methanol is CH3OH, like dragster fuel. And if it burns an oxygen, O2, and its products are always going to be the same. The products of hydrocarbon combustion will always be CO2 and H2O, and boy, do I need new pens. Okay. Now this one's tricky. This one's tricky, but you can simplify it a little bit by changing the way methanol looks. So you can change methanol by replacing the CH3OH with CH4O. Now understand, these are different chemicals. Okay? CH3OH tells you that there's an OH compound down to the CH3, but you can simplify it a little bit by writing that. So go ahead and try to balance this. It's not easy, but I think you can handle it. We're just going to go over the crossword on Monday. I'm sorry, what? It's been going, yeah, little bit by little bit. Again, it's only 3%. If it was 30%, it would go like you see on YouTube. But 30% hydrogen peroxide, you used to be able to buy it at Amazon. And then people said, this could hurt children. So Amazon doesn't sell anymore. You can't even ship it. You can't even ship it in an airplane.
So then what happened? So does isopropyl alcohol have nothing to do with this at all?
Correct. Nothing else.
It's like 90%.
All right. Are you balancing this?
Yeah, I'm trying.
Some of you got it? Michael's got it. Okay. Michael, how did you go about balancing this?
I put a 2 on the oxygen. 2.
You put a 2 in the oxygen to begin with?
Yeah.
All right. Why not? Sure. Okay. 2.
And then I put a 2 on the H2O.
Then I put a 2 on the H2O. And then that was it?
Yeah.
All right. So that was your end result, which is great. Again, if you find yourself, guys, if you find yourself with an even and an odd together, double everything. You can always reduce later. So let's check our work. How many carbons? 1. How many carbons? 1. How many hydrogens? 4. How many hydrogens? 4. How many oxygens?
1.
5.
Oh shoot, I forgot about the one in the...
How many oxygens?
Oh god.
3. Boom, 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 boom. Whoa.
I forgot about the other oxygen.
Yep. So let's use our fun little technique where we have evens and odds and we double it. So let's just put a fat 2 in front of there, a 2 in front of there, a 2 in front of there, and 2 in front of there. We can always reduce later, but by making everything even, things go quite a bit easier. Who thinks they got it now? Yeah. Okay. A 2 for the H2O. And that's it? Nope, we still have more work to do. Because we found out that would make it 5, 6, and 5. Or 6 and 6.
I put a 2 in front of the C4O.
Uh-huh.
And then a 4 at the
4 over here?
Yeah.
Alright, so this is a good place to start. So by putting a 4 here, we've got 2 carbons. 2 carbons, guys. We've got 8 hydrogens. 4 by 2 is 8 hydrogens. Now look at the oxygens. How many oxygens do we have on this side?
6.
2 by 2 is 4 oxygens. And 4 by 1 is 4 oxygens. For a grand total of 8. Can we make this side have 8? How would we do it? Replace the 2 with a 3. Because we've got 2 oxygens here, we're going to need 6 oxygens over here, and that's how you balance it. Again, it's like a combination law. A little bit left, a little bit right. A little bit left, a little bit right. Bradley, come up here. Are you scared of fire? Do you want to be a volunteer? Come on up and grab some glasses. I'm going to put a little methanol in this little container. Just a tiny bit. Just a few drops. So grab yourself some glasses. Over there. And this is just a barbecue sparker. You'll probably figure out what a barbecue sparker does. It makes sparks, right? It's a sparker, it makes sparks. So all you need to do is hold the sparker like this in your fingers and then push down on the trigger.
What? Nice.
Like this. Okay. Next one. Acetone. We have 38. Maybe I took the time. Guys, so hope you enjoyed that. That was a very rapid combustion of methanol and oxygen, and it happens several thousand times a minute in a dragster engine. And then, did you see the carbon dioxide and water vapor come out? No, they're invisible. They're gases. So the water actually comes out as gases. So you have a methanol, and it's actually the vapor of the methanol that does the reacting, not the liquid methanol. And let me show you why that is. Acetone is kind of an interesting chemical. You've probably encountered it. It looks like this. Here, if you draw it bigger, you've probably encountered it in various forms. Okay. And if you were to balance this, you were to condense it, you can condense it into C3H6O. Now, it's going to react with oxygen, and it's going to produce H2O plus CO2. Now, once again, guys, we have an even-odd situation. So what's our best strategy for even-odd situations? Double everything. Okay, so let's double this, double this, double this, double this. So try to balance that if you wouldn't mind. You can always erase numbers. I recommend you use pencil so you can erase numbers.
Why are you laughing?
Oh, 27, you're right, yeah. Okay, we'll pick this up again tomorrow. We'll pick this up again Monday.
What's wrong?